My name is Jonathan Maltz. If after this presentation you have any questions, comments, concerns, jokes that you want to send my way, you can do that through email, through maltz@yelp.com, or Twitter, GitHub, Slack, Instant Messenger, whatever you choose, through @MaltzJ. For those of you who don't know, I work at Yelp. Yelp's mission is to connect people with great local businesses. We do that by making a website and a mobile application that helps you connect with great local businesses. I am involved with working on our Android experimentation team at Yelp. So basically working day in and day out to build our next generation experimentation platform. So I'm dealing with all of these questions around mobile A/B testing every day. And before that, I worked on E24 back when E24 was a part of Yelp, committing code at every level of the stack from our Android client all the way back to our Puppet deployment systems. And that included a bunch of our data infrastructure. So what will we be talking about today? Today we'll be talking about A/B testing. And we're going to talk about a few specific areas within A/B testing. First and foremost, we'll talk about the what and the why of A/B testing. So if you've never run an A/B test before, you're not sure why you would care, hopefully I'll give you enough reason to care about why you should be running these within your team. Next, and the meat of this presentation will be on what's the actual infrastructure that you need in order to run an A/B test. So someone comes to you and says, we're going to start doing A/B testing. It's the best thing since sliced bread. What do you actually need to build in order to make that happen? And throughout the course of that, I'll be calling out which things you can buy versus which things you should be building yourself and where the trade-offs are there. And lastly, I'll be talking about some pitfalls to watch out for. Before we get started though, I did want to call out the fact that this presentation will not touch on the statistical foundations of A/B testing. So there's a large amount of literature around how to actually do these things right from a sort of mathematical and experimental and statistical perspective. And it's important to understand that if you want to become really proficient at A/B testing. If you're looking at where to get started, you're going to want to look around for things like controlled experiments, sample sizes, or confidence intervals. All of those things are really important, and I include some resources at the end for where you can find information on those. So first, let's talk about why you should be A/B testing. So the classic example of what an A/B test is that you have some button in your application, and you want users to click on your button more. And your button's currently green, so you say users click on red buttons more. So we should make our button red. So you go, you ship an app release, and you change your button to red. You're like, awesome, we get more clicks on our button. And we should all change all of our buttons to red. And then before you do that, you take a second, and you maybe look back at some old applications versions where the button was green. And you see on those versions, you're getting more clicks on your button as well. So what's going on here? Is the button color change actually the thing that's driving more clicks? Or maybe did you just make your API responses faster? So now, as a result, people are just interacting with their page more, and so they're just going to click on anything you put in front of them more. You need a way to determine what features are actually moving the things that you care about. And the way that you do that is you run an A/B test. So you take 50% of your users, you give them an A experience. Sometimes we call that a status quo experience, which is the existing experience within the application. And then you take the rest of the users, the other 50% of your users, and you show them that red button that you have. And then you hold as much as possible everything else consistent. And there's some caveats there, but for the purposes of this, we'll just say keep it consistent. If we keep everything consistent, then we'll be able to measure things accordingly. And then what we're able to do is we're able to say whichever of these button colors got more clicks is the button color that people are clicking on more, because between these two cohorts, nothing else has changed. And this is a super powerful methodology, because once you start A/B testing as a way of building your products, it forces you to be fact-driven, or fact-focused and data-driven, fact-based and data-driven in the case of this slide. Before you start A/B testing, it's really easy to say things like, oh, our users definitely would love it if all of our buttons were red, and so we're just going to turn the buttons to red, and won't our users love that? After you start A/B testing, the way you talk about your new features just changes. It becomes, I have a hypothesis that our users care about this particular thing. And the way that we're going to test that hypothesis is we're going to instrument this experiment. And then we're going to measure that experiment by tracking these 3 things within our app. And as a result, you're able to start generating more and more insights about what your users are actually doing. And the great thing about this is it allows you to inform the hippo, or the highest paid person's opinion. Before you do A/B testing, it might be really hard to just, if someone comes to you and says, I think we should do this thing. I think we should change all of our buttons to red. And you're like, I think red's an ugly color. And it just becomes this battle of wills where like maybe the person who just gets paid the most wins. Once you have A/B testing in place, you can say, we don't really know if this is a good change, but let's test it, and we'll see what happens. And we'll let the data decide which of these experiences we choose for our users. So now you're on board with this, and you're like, great, I love A/B testing. It's the best thing since sliced bread. How do I do it? And there's a few key pieces to running effective A/B tests. The first is you need a bucketing system. So this is the thing that's actually going to divide those users into the 50% who are seeing the status quo experience and the 50% who are seeing the new experience. That bucketing system is going to send allocation information down to your app. Your app is then going to be logging on-device events, so things that your users are doing, whether it's interactions with things that they're clicking on, push notifications that they're receiving, or views that they're seeing within your app. I also might use the term analytics or even metrics for these types of on-device events for the purposes of this presentation. Basically, the idea here is you're tracking what your users are seeing and what they're doing. After you do that, you're going to send that into some sort of metrics collection pipeline, which will transform and decorate that data in any way that's important to you. And then you'll send it on to a metrics service where you can actually do analysis and figure out what your users are doing with your application and if your experiments are working. So to get started, let's focus on this top left piece, which is the bucketing system. At a high level, the way your bucketing system is going to work is that you're going to take some identifier, maybe a user identifier or a device ID. You're going to put that through some randomization function, maybe it's a hashing function, and then out the other side is going to come a bucket. And the way this will work is you're going to take the output of that hashing function, and it's probably a 32-bit integer between like 0 and 2 billion, and then you're going to modulo that by 100. And now what you've done is you've reduced all of your user IDs, or whatever you're bucketing on, to a range of 0 to 100. And then what you're going to do is you say, we're going to take the first 50 of those numbers and show them the green button, or the status quo experience. And we'll show the people who get the last 50 numbers there, so 50 to 100, we're going to show them the red button, or the treatment experience. So now you're like, cool, easy peasy, lemon squeezy, I got this, I know hashing functions, like I'll just call the MD5 and we're good to go. And the raccoon says not so fast, my friend, because there's actually a lot of errors that you can run into with your bucketing system if you're not conscious of how you're actually ramping up your experiments and allocating users to buckets. So to understand that, first, one of the important things to understand about controlled experiments is that you only want your users to change their experience at most one time. So if you have a user that is currently seeing a green button, it's okay for them to change into that cohort that's seeing a red button, but you don't want them to flip back to the green cohort, then back into the red cohort, and back and forth and back and forth and back and forth. At that point, you basically need to just restart your experiment and rerun your analysis because a lot of the invariants that you need are invalid. So in the case where you're just ramping up an experiment, this is fine. The user switches once from the green experience to the red experience, and then they stay in that red experience for the rest of the experiment. Things get a little bit more complicated, though, once we start having more than just a green button and a red button. Say now we want to test a red button and a yellow button. To start out, our user might switch from the green experience into the red experience. But then once we ramp up both of those cohorts, let's say our user got the value 7 here, then they're going to move from that red experience into the yellow experience. And now that's violated our invariant of we only want our user to change one time. So again, in this case, what you would have to do is basically restart your experiment and throw out the data that you have so far. Now, the solution to this type of problem is that what you can do is allocate sort of what I call buffer cohorts. So the idea here is in between as you start ramping up your experiment, you leave some space for each of the treatments to expand into. And those buffer cohorts, so this sort of dark yellow and dark red here, initially those people are going to see the status quo experience. But as time goes on, the treatment experiences are going to go to expand to fill that space. So in this way, we're able to have multiple cohorts, but still enforce the fact that our users are only making one switch into a treatment experience. The other big thing to remember here is don't forget the salt. Now, for those of you who are familiar with hashing functions, or who aren't familiar with hashing functions, a salt is sort of a little additional piece of data that you give to your hashing function in order to make sure that your data stays randomly distributed. And this is important because if you're not salting your hashing function when you actually allocate your users into cohorts, what you'll have happen is a user, say their value is 23 for their identifier. They're going to end up in the status quo cohort for every single experiment. And now the experiments are not independent from each other. So you can't say that you can't, for example, run 2 experiments on the same page and say like, well, our users will just be randomly assigned to both of them, so it's okay to run those experiments simultaneously, because in a very real sense, the experiences are not independent from each other. The solution to this is actually really simple. What you do is, instead of just hashing an identifier, what you do is you hash an identifier and then you append an experiment name before you call the hashing function. And so in this way, your users will get evenly distributed across that range, and it'll be random according to the particular experiment. Now, how do we actually implement this bucketing system? There's 2 approaches. The first is the sort of vanilla standard approach, which is really great if you're just getting started. And that is, you have a config file and a buckets endpoint. And the way this works is that you have a mobile application which sends its identifier to the backend and requests cohorts, say with a bucketing endpoint. That backend will go and parse some sort of YAML file, and it will then send that identifier through the hashing function, and it'll retrieve all the cohorts for that user. Then, on your application, oh, you can see this, sweet, contrast plus plus. On your application, you're going to have code that looks something like this. You're going to say, if my user's in the enabled cohort, show them white text, otherwise show them black text. And this is really awesome as a first pass approach. It's super easy to implement, and it's also really easy to understand. It like very much matches one-to-one with that idea of we take some users, we put them into a bucket, we show them different experiences depending on their bucket. Now, the downside here is, first and foremost, your cohorts may not load in time. So if you're trying to run something like experiments on your app startup or on your app's onboarding flow, which happen at startup, you either need to block on the network request coming back, or maybe what you need to do is you need to figure out some way to account for the fact that your network request hasn't come back yet. But regardless of what you do, this is something that you can't ignore, that you're blocking running experiments on getting a response from your server. The other thing is it becomes really hard to handle complex conditions. So on an application like E24, we had, say, 2 or 3 screens that we were experimenting a lot on. And as a result, we started having to run like 6, 7, 8 experiments on our restaurant list page, all of which were related to each other. So it became really hard to figure out how many carousels should we show at the top of the page and what should be in those carousels. Because for every one of these experiments, we had this explosion of, if we're in bucket A for this experiment, but bucket B for that experiment, then we should show this different thing. So the way to solve this is something that I'm not exactly sure what their official name is, but I call them parameter experiments. And the idea here is that instead of requesting cohorts from something, what you do is you request parameter values. So you have a mobile application, and then what that does is that requests a parameter from your experimentation system. Then the experimentation system again goes, it reads a configuration file, and it retrieves the appropriate parameter value. Now, your code is just going to look something like this. So you instantiate an experimentation system, maybe you inject it through something like Dagger, and then what you do is you just say, set my text color to whatever the experimentation system says that the value for this parameter is. So the advantage here is that as a client developer, all of that complexity of having to run all of these interrelated experiments just goes away because you push all of that down to your experimentation system, and you don't need to think about it nearly as much. This means that you can handle really complex conditions and really complicated experiments really, really well and really, really simply. And if you're running into situations where you have to handle these complex conditions, I would advise you to take a look at this type of approach. Now, the downside of this is now you have something else that you need to do this parsing of this configuration file at runtime in order to find things that might show up on your UI. So if we go back to the previous slide, if this is something that's happening in, say, when you're inflating a view item and you have a lot of these parameters that you're trying to show, that might become a non-trivial performance penalty that you're paying in order to handle these complex conditions. Also, you can still do this with an approach where you're requesting your parameters from the server, but in that case, you might get a lot of parameters, because if you think about everything you could possibly want to experiment on in your app, that's like a lot of stuff. Some other things to be mindful of with your bucketing system are you're going to want some way to do defaults. So you're going to want some way to say that for whatever reason, I couldn't get allocation information for this user, show them a default experience that's like sensible and good, and log the fact that we couldn't actually get a cohort for them. Next, you're going to want to be able to override stuff through something like a config menu. So it can be really frustrating, like refreshing a web page and being like, please put me into the B bucket, please put me into the B bucket. Or having to cut an application build anytime someone wants a particular experiment experience. Try saying that 10 times fast. Experiment experience. Good, I got a chuckle. Nailed it. The other thing you're going to want is you're going to want whitelisting within your bucketing system. So you're going to want the ability to say, for example, roll this out to all of our employees and our internal users before we go and roll it out to everyone publicly. And again, you're going to want to be able to do that without having to ship an application build that hard codes a particular experience, because over time that just becomes a pain as you have more and more of these experiments. Now, some options for reuse here, if you're looking to take something off the shelf and make it work. If you're looking for a traditional bucketing model, Optimizely, Aptimize, and Mixpanel, this is basically their big value proposition, is they do A/B testing as a service. And they will have this type of bucketing model, and they'll handle all of those edge cases about bucketing that I mentioned before. These are really great if you don't have a lot of knowledge about the statistical side of things, because they'll also give you a lot of support around things like statistical significance, making sure you have a large enough sample size, et cetera, et cetera, et cetera, all that other stuff that you would probably stumble around and try to find on your own. If you're looking to do something parameter-based, Firebase Remote Config is a good way to get started with this, but it isn't really an experimentation platform. It's kind of like shoehorning Firebase Remote Config into this situation, but it can do a lot of this type of parameter stuff. The other thing is Facebook's Planout library is fully featured and provides a lot of really great ways that you can interact with this type of parameter experimentation. And it also has a lot of primitives for a lot of different types of experiments that you might want to run. So take a look at that if you find yourself wanting to build that type of system. Next, we'll talk about the on-device logging piece, which is this middle piece. Now, the unfortunate thing about on-device logging is that I can't really stand up here and say, like, there's an obvious solution that you can just drop into your application and just follow this application pattern, and like, congratulations, your on-device logging will be solved. You're going to want to be logging, everyone's going to want to log different things, they're going to have a different application architecture, and they're going to have a different history with their app. So there's not like a single thing that you can just do and call it a day. There's a couple of options I'll mention at the end of this section, but there's really nothing perfect. What there are, though, there are some central principles that you can follow that will help make this process easier and scalable for you. First and foremost, you're going to want to define domain events, and then you're going to want to delegate the formatting of those domain events to particular metric services. So what I mean by this is that if you, for example, Google Analytics has this model of you have all of its events have categories, actions, and labels. And so if you start by instrumenting Google Analytics in your application, then you can say, oh, okay, everything has a category, an action, and a label. That's great. But then what happens when you say want to start tracking things to an internal metric system, or maybe something, a third-party system like Adjust that has no concept of these things? Now, maybe you need to duplicate your analytics, or you need to like shove your data into some weird format just so that you can get it to work across all of these different services. Now, a much better way to approach this type of problem is to define events in the language of what's actually happening in your application here. So if you look, in this case, what we say is we have an event called search.bar.text.update. And you can just read this and you already know what's happening. You're on the search page. Inside the search bar, someone updated their text. And now the great thing is you can send that into an event manager. And if you sort of have that if you have those events in a schematized format, you can then delegate that event to every interested service. You can send it to Firebase Analytics processor, and an Adjust processor, and an internal metrics processor. And that can format the information in any way that's valuable for you. Now, as you're doing this, there's a couple of types of metadata you're going to want to attach. So you're not just going to want to track events, because otherwise you wouldn't actually be able to attach any sort of cohort information or any useful metadata about your users at all. The first type of metadata you're going to want to attach is this idea of common metadata. So this is something like a timestamp or a user ID, and that's going to be something that you want to attach as much as possible as late in the pipeline in your event manager, because otherwise what's going to happen is if you leave it for an event by event case, someone's going to call it timestamp, and someone's going to call it date stamp, and someone's going to call it date timestamp, and someone's going to log it as milliseconds since epoch, and someone else is going to log it as ISO 8601. And before you know it, your data analysis just becomes a mess, because in order to analyze this one piece of data, it can be represented in like 10 different ways. If you centralize that and make it so that users just of your analytics system just don't need to think about attaching it, that solves that problem once and for all. At the same time, you're going to have some application-specific or event-specific metadata. So, for example, for our text being updated here, you might want to say what the text went from and what the text changed to. And that's not really useful to have that field on every single event that might happen in your application. So, if your user views your video page, there's not going to be any text that's being updated from and to. So you're going to want the capability to attach that to your events as they happen. At Yelp, we do this by having a map of strings to objects that can be attached to any analytic event. The second thing that's really important is that developers own analytic definitions. I think this is really important to call out because sometimes it can be really easy to think that the actual processing and analysis and the definition of the data is something that's the responsibility of product managers or data analysts or business operations. And that can lead to some really pernicious situations. So, for example, you can get into this situation where your product manager is saying, we need to track this thing. Track it as this. Track it as search underscore bar underscore text underscore update. And then you're just like, OK, cool, we'll do that because I don't care about how this data looks. And that becomes really problematic because that then means that you now are letting this complexity of maybe having multiple different schemas for your data creep into your implementation. So if we think back a few slides to this example where we're delegating formatting, now each of these services needs to be aware that maybe we have some set of events that are delimited with periods and some are delimited with underscores. And we don't gain anything from that complexity. It's just complexity that comes from the fact that the person who defined the analytic is not the person who's actually instrumenting that analytic. This can also become really, I've seen this happen a bit with how additional parameters are attached and whether you sort of have nested dictionaries or flatten out that dictionary. So a much healthier way to do this is that your product manager or data analyst says, we need to know when the user updated some text in our search bar. And you're like, OK, cool. Like, track that as search.bar.text.update. And congratulations, whoever's analyzing that data can still use that just as well as they could before. And you've kept a lot of internal consistency within your application, and all of the logic that you need is much simpler. The last piece is that you want to keep your documentation as close to the code as possible. This is true of pretty much everything that you're going to be building, but it's especially true of analytics, because as your team grows and you start tracking more and more things, what you'll find is that you have a lot of events, and it's really hard to keep track of like, oh, what do we call what happens when a user views this particular page? And if you're not conscious of continually updating the documentation, people need to start digging into the code or asking an engineer in order to find out how do we track this thing. So one approach that you can use to make this happen is you actually code generate your analytics yourself off of the documentation. So one way you could do this is you have like machine readable documentation, which you update anytime you're instrumenting a new analytic. Then what happens is once that's updated, you run through some sort of code generation system like Java Poet, and then you generate a lot of Java analytic objects, and you publish that to an internal Maven repository that's pulled into your application. So the advantage here is now, in order to add a new analytic to your application, you in a very real sense have to update the docs because there's no other way to create objects unless you're just going to like circumvent the entire system. Now, I mentioned that there weren't any silver bullets in this. And to some extent, the last two things don't really have a silver bullet. If you're looking to solve this problem of trying to send messages to a lot of different event services, this is the value proposition of Segment.io and mParticle. Both of them will take events from a bunch of sources and delegate them out to a bunch of to other sources. So if you find yourself in this position where you're experiencing a lot of pain from having to send events to a bunch of different places, look into one of those and they might be able to help. Next thing I wanted to touch on is this question of event deliverability. So it's this middle step here. So once you log your events into your metrics collection pipeline, how do you actually get them to a metrics service? And this is mainly a problem if you want to do internal metrics collection. So if you're just sending your data to something like, to a third-party service like Firebase or Adjust, then this isn't really an issue because they're going to give you SDKs, and those SDKs are going to take care of buffering your events and making sure they get delivered. The dirty secret of all this is that you're going to want to have internal metrics collection eventually, though. And I'll touch on why that's the case later. But for now, I ask you to trust me that eventually this is something that will be your problem. So the general shape of the problem is this. You have some analytics in your application, and you go and you send them to your backend, and when everything comes back successfully, you're living the good life. Things get a little bit more you clear out your analytic queue, and you're good to go. Things get a little bit more complicated once you send your events, and then a new analytic comes in. Now your queue is in a slightly dirty state, But if your response comes back successfully in a reasonable amount of time, you can still figure out how to deal with this. Maybe you have 2 queues, maybe you hack particular analytics. Like, it's pretty easy, it's pretty straightforward to deal with this. However, what happens if you send these 2 analytics and they're in flight, and then the user exits your application? Maybe you're on a slow network and they say, okay, I'm done with this now. Like, what do? Do you, next time they open the app, do you resend them and risk people double counting, getting your analytics double counted? Do you just say, we'll just assume they got there and have a best effort attempt at that? And the answer is, there really isn't a perfect answer here, and it's all about trade-offs. Because basically this is like kind of hard distributed, or a pretty hard distributed systems problem, and if you're trying to solve distributed systems problems on Android, chances are it will take you a long time to get it perfect. So some of the trade-offs to think about here. The first one is, how many analytics are you actually losing because of this? If you have a way to get a sense, maybe you have 2 different analytics services that you can compare against. If you have a way to get a sense for how many of these are actually not reaching my backend in time, or how many are getting duplicated, that can be really important to guide your decision here. The next thing you're going to want to do is, how important are those analytics? It can be really tempting to think that all of these are created equal. But for example, at Yelp, if we drop ad clicks, that means that we are then losing, like in a very real sense, losing dollars from our bank account. Versus if we lose a user profile event or 2, like that's not great. And we'd like to avoid that if possible. But if we're 0.1% off on those, like the world continues to turn. And it's okay. The other thing you want to consider is, what's actually the cost of gaining back these analytics? And the reason this is important is because, again, as you start trying to get more and more precise, and you start to get closer and closer to 100% of your analytics delivered and processed, you're going to find that it costs you more and more to get that additional marginal percent out of your system. So again, there's not a perfect solution, but some building blocks to consider with using this. The first and foremost is this concept of analytic channels. So if you have really high priority events, you might want to immediately flush those whenever you get one. So immediately send those ad click events to your backend. But other events you might want to buffer up and say, we don't need to be always using our users' radio and draining their battery. So we'll batch those up, and maybe they'll get dropped because the application crashes, but that's okay. Another thing is, structured flat files can be really powerful for this. So just taking the contents of some data structure and dumping it in JSON to a file and persisting that file and retrying to send that file can be a really simple and powerful approach to solve this problem. Also, job managers, whether it's Firebase or Evernote's approach, are really useful for this. Also, SQLite databases and tape queues can be great ways to think about persisting your events. Tape is, for those of you who aren't familiar, is a queuing library from Square, which makes 2 obligatory Square library references in this presentation. No RxJava references, though, so that might make me heretical. And no Kotlin. So an example of how you might want to solve this problem that is a simple approach and deals with some of these trade-offs pretty well is when your event comes into your event manager, you take that and you write it to a tape queue. And then what you do is you check your tape queue and ask if it's over a flush threshold. So if you have, say, maybe if you're trying to channel your analytics, maybe your flush threshold is 1 because this is a high priority analytic queue. Maybe it's 20 or 30 because these aren't as high priority. If you are over that flush threshold, then what you can do is copy the contents and then create a persistent job, dispatching it with something like the Firebase Job Manager or Evernote's Job Manager. And this is pretty similar to what we do at Yelp. We flush analytics every 30 seconds and every 20 analytics once those 2 conditions have passed. We always send our analytics via a job manager job, and we also flush our analytics immediately once the application goes into the background. And also, in some particular cases, we'll immediately flush our analytics once particular ad impressions have been delivered, because again, that translates to dollars in our bank account. And the thing to realize about this system is it's not perfect. We know that we're losing a little bit of data. It's not a lot of data. We've analyzed it, and I think it was something like we're losing 0.3% of our analytics are getting delivered late. But it's fine, and we are aware of the trade-offs that we're making, and we decided to move forward with that instead of trying to chase those last couple of percent at the expense of other more valuable features for our users. Lastly, I wanted to talk about the analysis piece of A/B testing, because ultimately you want insights, and that's what this piece is for. So it's this step of having metrics, the metric services up here. So there's 2 main questions you're probably going to want to answer with your analysis. The first is, does funnel conversion increase? So the concept of funnel conversion, for those of you who aren't familiar, is that you define sort of a series of events or a user journey through your application. And so for E24, for example, our users started on the home page, then they go search, and then they start an order and eventually complete an order. And you have 100,000 users who start the order, 80,000 who search, 10,000 who actually start an order, and then 5,000 who actually complete. And what you might want to do is run an experiment at any step in this process and figure out, if I make this change on the search page, do users start more orders, and do those orders become successful more frequently? So what happened, the particular language is you try to limit drop-off within the funnel as much as possible. And the big thing to understand with this type of analysis is that you don't want to be reinventing the wheel. In order to do this type of analysis effectively, you need to have the concept of a session within your analytics. So if you have an internal analytics system, you need to basically bucket those by some concept of this is an active window of use. And that's something that's actually kind of hard to do if you're starting from scratch. If you have a bunch of data infrastructure, you can use stream processing tools like Flink or Spark to do this for you. But if you don't have existing data infrastructure, that's a lot to get up and running and make sure that stuff's getting delivered and sessionized correctly. At the same time, a lot of these third-party metric services are going to do this for you. So they know that this is one of the important things for A/B tests. So I would advise you to take a look to not build this type of system if you don't have to. The other type of question you're going to want to answer is like, do users click on buttons more? Do they order more food? Do they watch more movies? Do they like order more lifts rides? Like basically, do they do a thing? Do they click the button more frequently? Do they do the thing more frequently? And there are like so many options about how you can pay people money to solve this problem for you. You can have like Amazon's App Analytics. You can have Apps Flyer. You can have Firebase Analytics. You can have Branch. You can have Adjust. You can have Keen.io. You can have Flurry. I think that's all the ones on this slide, but I'm not sure. And the thing with this is a lot of these sort of, in some ways, follow the Unix philosophy of doing one thing and doing one thing well. That's a little bit of an overstatement because some of these are more general than others. But for example, Amazon's product, I know that they're really good at calculating and surfacing like revenue per user and average revenue per user, versus something like Branch or Adjust might not have that information. So oftentimes, you'll also find different people in your company are going to want to use different ones of these. So your marketing team will probably want to use Adjust, whereas your internal product management team might want to use something like Flurry. That's why it's important to have that type of infrastructure I described before, where you're delegating events effectively. If you're looking for a decent catch-all to get started, Firebase Analytics is a really great approach. They have a lot of tooling in place, and they will allow you to solve a bunch of problems and scale up fairly effectively for you. Now, I mentioned before that you're going to want to have an internal metric system, and I asked you to trust me, and the reason that we've now gotten to the point where I'll hopefully pay off that trust. And the reason you want that type of internal metric system is because eventually you're going to want to join your experiment data, because you're going to want to ask longer-term or more complicated questions. So you're going to want to do things like calculate your search click-through rate. So you're going to have a search system that's writing data to its logs, and you're going to want to join that against your user experiences on your mobile clients in order to figure out search CTR. Or you're going to want to calculate 90-day retention or something like that, maybe lifetime value of a user who was in a particular cohort. And it's really, really hard to do that with one of these third-party solutions. So there's a couple of options for how you can solve this problem. First and foremost, Firebase offers BigQuery export, which is a really handy way to get started solving this problem. What this is Firebase will basically dump all of your data into a third party, into Google's BigQuery database, and you can then query that, and you pay by the terabyte in and out and the amount stored. This is really great because it solves the problem. In some ways, this solves the problem for you. You can write Python scripts or JavaScripts or whatever scripting language you want to use. You can make queries against BigQuery. You can take those results. You can join them against your application database or whatever else you have, and you can get the insights that you need. And it's like 2 clicks. It comes out of the box with Firebase, so it's not hard to get it set up. Now, the downsides are, like so many things with Firebase, first and foremost, it can't be backfilled. So if you have an internal metric system and you realize that, our users, we weren't tracking this thing, but we can derive it from some existing user data, you can go run a backfill job and get that data within a couple of hours. You can't backfill data into Firebase. You're also still limited by whatever Firebase has and whatever their limits they place on you are. So I think they have like 25 properties that you can set. and some other limitations that I don't really remember. But basically the idea here is if you want to start running lots and lots of experiments, either you're going to need to start paying Firebase lots of money, but at a certain point, you're also just going to hit the wall of what Firebase will give you. And the other thing is you probably need to write scripts on top of this. Regardless of if you're within the limits of what Firebase provides, you're going to need to have some scripts, and you can't just query your data using raw SQL. You're going to need to write a script that says get the data out of BigQuery, and then join it against my internal database. Now the second option here, and this is sort of the giant hammer to take to the problem, is that you have an internal metric system. And this probably looks something like you're logging your events to your backend, which is then logging them to some sort of stream aggregators, whether it's Amazon's Kinesis, or maybe we use something like Scribe. But eventually those logs are going somewhere, they're getting stored in S3, or whatever log storage system you use. And then they're getting ETL'd into a data warehouse where they live co-located with all of the rest of your data. So now you have this giant data warehouse cluster that has all of the usage of your application. The advantages of this are, obviously, you have maximum control, so you have maximum power and flexibility. You control exactly how your data is stored. You control how much of it you retain. You control all of that. And that means that over time, you can backfill things. You can start to execute anything you want to execute using just SQL. You can do stream processing in order to get more complicated analytics on top of this. The downside is you need to maintain this. So your ETL jobs, even though you set them up, they're not going to run perfectly every time. And someone's going to say, why isn't there data from Tuesday in the data warehouse? And someone needs to go figure out why there isn't data from Tuesday. So there's a fairly high cost to not only reach feature parity in terms of deliverability, but also the analysis features that third-party services provide. But at a particular point, that cost is worth it. For a company, especially at the scale of Yelp, like we are just reaching the limits of how much money we can pay these third-party services and the inflexibility that they give us. So we're migrating to an entirely in-house solution right now. So they always say that you should take 3 things home from a presentation. I hope that you're taking more than 3 things away from this. But if you're curious about my 3 things, first and foremost, A/B testing will help you build a more data-driven culture within your company. And that's valuable even if you're not doing A/B testing perfectly, in order to build a culture of actually figuring out what your users are doing and forming hypotheses about how they want to use your product and how to build them something they want. The other thing is you want to know the basics of statistics before you start A/B testing, so that way you don't run into some of the pitfalls that I mentioned earlier. And lastly, don't treat this as someone else's problem. Don't say, I'm not the person who actually cares about these data insights, so I'm just going to make a crappy end-to-end pipeline. Because ultimately, this type of stuff is systems that you're going to need to maintain, and you care, if you care about the future of your product, you care about the quality of the analytics that you're sending. So some resources for you. First and foremost, expplatform.com is a website that does not look very attractive, but is absolutely amazing. It's from the Bing experimentation platform team, and it has papers at every level from introduction to A/B testing, which is A/B testing at scale here, to super, super deep problems that people only at Bing and Google and Facebook scale encounter day to day. Next is Twitter has a unified logging paper, which describes the schema that they set up for their own analytics. Solid Analytics with RxJava is a blog post that describes how to build the type of system I described before, where you're delegating events to multiple analytics services and defining your events in the language of your domain. Lastly, tools on statistics from our data science team. 1, a concise guide to statistics. That is the best I've said that in all of my times practicing this. I'm very excited. Is a concise guide to statistics. Next is causal inference in statistics. This is a next level thing if you want to get really deep into statistics and find out all about that. That's a great resource. Lastly, Optimizely's sample size calculator is really great if you want to make sure that you have enough people in your experiments in order to actually get statistical significance. So thank you for attending. My name is Jonathan Maltz. My email is maltz@yelp.com. My website is maltzj.com. My Twitter handle is at maltzj. I work at Yelp. We're hiring. Come check out our booth. Does anyone have any questions? Question in the back, then question in the front. Can you please use the microphone, just so that they can record your question?
So you mentioned that you use a unique ID and a modulus function to do user bucketing. Is there a reason to do that rather than assigning via random number and doing that at assignment time?
When you say assigning via a random number, well, so one of the things you want is you want repeatable bucketing. So you want, if I am in cohort A in the red-green button experiment, you want me to always be in the green button experiment until I get to until it's time for me to swap over, until you ramp up that experiment. So if you're using a random number, you maybe could make sure that random number is the same every time. But the idea with having an identifier and an experiment name is that those are going to be consistent across the lifetime of the experiment.
So it saves you the trouble of like syncing it back and forth with the server, basically?
Yeah, and the biggest thing there is that those two things aren't going to change across the lifetime of the experiment. So I need to process a little bit in order to figure out exactly what you're talking about with a random number. But the big idea with the identifier plus experiment name combination is that those two things aren't going to change. And so a user will always get cohorted into the same value, which means that every time they're exposed to that experiment, it'll be the same thing until you want them to change.
Got it. Makes sense. Thanks.
Welcome. One over here, then, please.
Yeah, you mentioned on your pros and cons slides about traditional bucketing and parameterized, the problem of experimenting very early and your server not delivering data on time so you can do bucketing.
Yep.
On the parameterized slide, you didn't list that as a con, but it would seem that you'd run into the same problem. How did you deal with that?
Yeah, so we're in the process of dealing with that now. Basically what we do there is you can ship your configuration with your client. So your configuration is like a static JSON file, and since since your experimentation system is just referencing that config file on device, then you can read the parameter values from that. You basically don't need to block on getting a response back because you can do everything you need to do on the device. You could theoretically do the same thing with a traditional bucketing model. So you could ship all of your cohort information with the application and then retrieve from there. The one thing there would be you need to keep the logic for bucketing in sync between your server and your client. The thing that we're currently doing right now is we actually have a cross-platform, we have a bucketing system that's cross-compiled to all of our possible targets, so Android, iOS, and web, to make sure that logic is consistent across all the places. The other problem if you're going to do that, is you need to make sure that configuration gets updated. But at a high level, the problem exists so long as you are requesting information from the server, and it is a little bit simpler to avoid requesting information from the server in a world where you run the experimentation system yourself, as opposed to having to share that logic between clients. But you could theoretically make this not, as I mentioned before, there are ways around this problem, but I wanted to call it out as something on the traditional bucketing slide. So half an oversight, half it's easier with the parameterized model as well.
Thanks.
Yeah. Question over here.
All right. Thanks for the talk. So when you do the debugging,
yeah.
Do you have to rewrite the code, or do you have anything like feature that you can just switch it on the experiments?
So when you do debugging, are you talking, what part of debugging are you asking about?
Let's say you change the color of button, right?
Yeah.
And do you want to check if the red just comes out as red?
Yep.
Then, yeah.
Gotcha. So your question is if you have all of these different possible experiments, how do you make sure that you're appropriately testing each of these experiments? We have a way to we have something in our application called an experiment manager, which allows you to mock being in a particular bucket. And so in a very real sense, you have to test both of those experiments. This is one of the challenges with, again, that when you have all of that code complexity in a traditional bucketing model, is that the possible number of states that your application can be in and you need to think about becomes much larger. But the short answer to your question is there isn't really a way around it. You just need to mock your you need to mock your application getting into the state that you care about, and then you do whatever you want to do, and then you assert that your desired state is the state that you want. So I guess there isn't really any magic there. It's just you need to test your experiments the same way that you test your application code that isn't being experimented on.
Oh, I see. So you have to change the parameter from server, or?
So ultimately, your server is going to whatever system it has is going to return back values that are going to get stored somewhere. Yeah. So basically, what you need to do is you need to mock out your bucket, and whatever the system that you're using is, that's ultimately you need to say whatever I'm experimenting with, pretend that is giving me back the red button version, and then make sure that my application works appropriately.
Okay. Thanks.
Thank you. All right, I think that's time. I'll be around if anyone has more questions. Thank you.